All right, welcome back, everybody. What we're going to do today is continue with our introduction to basic statistics, and I'm going to start talking about section 1.2 of the textbook, chapter 1, section 2, sampling techniques. So let's just jump right into it. Sampling is actually a really important concept to understand. It's not difficult, but it's very easy for bias to be introduced into sampling. So let's understand this basic point, that the science of statistics is really always focused on trying to control bias. And sampling does indeed provide a great example for that. What does it mean to have a study that is biased? Well, if a study is biased, it means it's designed to kind of favor certain results. And of course, we don't want to have a study designed to favor any one type of conclusion. We want to know what's the truth, what's the real answer. So that would be an unbiased study in which the true answer can really surface to the top. Let me give you an example of what I'm talking about. You might be familiar with USA Weekend magazine. It comes like with our local paper here in Zanesville, and I think at least on Sunday mornings, and it probably comes in many newspapers. And it's just, a little periodical with some interesting things to read. Well, USA Weekend magazine recently asked readers to return a survey with a variety of questions about violence on TV. A lot of people claim that TV is pretty darn violent nowadays. Of the 65,142 readers who responded, which is an enormous sample size, 65,000 people responding to this survey, that is a lot of data. Of those people, 97% were somewhat concerned or very concerned about violence on TV. And I'm imagining that that is what we used to call, when I did marketing research, top two box. So if you imagine some boxes that you can check on this survey, the top one says that you were very concerned, the second one from the top says somewhat concerned, and then below it are other options. Well, 97% were either somewhat concerned or very concerned about violence on TV. So here's my question to you. Can we conclude that approximately 97% of US citizens are concerned about violence on TV? Because ultimately, that's probably who we're trying to learn about. We're trying to learn about people in America and what they think about violence on TV. So from those 65,000 readers who responded, which is a huge sample size, can we conclude that 97% of US citizens are concerned about violence on TV? Well, if this sample was drawn appropriately, if this sample is unbiased, then we can indeed learn about the US population. But if the sample is biased in some way and they don't really represent the people in general of the United States, then what we learn from those 65,000 people isn't going to necessarily tell us anything very precisely about the US population. Let me just kind of get you on the right track here. Think about it for a minute. How many people get the newspaper, and of the people who get the newspaper, how many people are reading USA Weekend magazine? Do those people represent the US population very well? And then think about it this way. Let's say you're reading something and many other people are reading something, and let's say they actually, all the readers of this magazine, represent the US population pretty darn well. Let's say that that's true. Well, how many of you are going to actually take the time to return a survey? Is it possible that only certain types of people are going to be more likely to fill out this survey about violence on TV? So, do you see what I'm getting at? Because if that's possible and only certain types of people are going to be more likely to return that survey, then our sample is obviously going to be biased, and that sample of people and their responses will favor certain types of results. And then are we going to learn about the US population and how they feel about violence on TV? Not really. Bottom line, the reason why I'm talking about this example at length is because sampling is so important. We can conduct a study with a huge number of people who have responded and learn nothing. It's a complete waste of time, complete waste of money. So we need to make sure we understand sampling. Let's get into it. Why is sampling such an important step in protecting against bias? Well, there are a few reasons, and I've alluded to them a little bit. Number one, a study can be successful only if the sample is representative of the population. Anytime we talk about sampling, the very first thing that needs to come to your mind is this sample likely to be representative of the population? And when I say representative of the population, I'm really trying to say, is the sample like the population in important characteristics? Does it have the same breakdown of men and women? Are people represented in terms of their race? Are people represented in terms of their economic levels? Are people represented in terms of their religion? All kinds of things like that. A biased sample is unlikely to be a representative sample. That's pretty obvious, right? If we have a sample of people who we've chosen in such a way that it's not really very fair, it's not likely to get a good cross-section of America, if we're interested in learning about America, if we're unlikely to get that good cross-section, then it's unlikely that that sample is going to be representative. So we want to try to eliminate bias to maximize representativeness. And don't forget too about sampling error. Even when we use really good sampling techniques, there's always going to be some difference between the real data from the population and the data that we find from our sample. So even with a wonderfully chosen sample, there are going to be some differences between our sample data that we collect and the real answer that's out there that we would have found if we measured the entire population. Well, we certainly don't want to add bias. We don't want to have bias sampling added to sampling error. That's just going to compound the problems with our results. All right, so that's why this is a really important issue. Let's talk about some common sampling techniques. Here's a list of them that we're going to talk about. These are relatively common: simple random sampling, systematic sampling, convenient sampling, cluster sampling, and stratified random sampling. These are listed in your textbook. I'm listing them here. You look at the basic definitions, but it's gonna help if we go through some examples. Let's do that next. Let me make this point before I move on. Every sampling method has its time and its place. I'm going to tell you about some that seem better than others, but really, if we're going to be fair, it's that sometimes one method seems better than others in a certain situation. Every single one of these sampling methods has its time and its place. They all have strengths and they all have weaknesses. That's what we want to learn. We want to be able to not only identify a sampling method when we read about it, when we learn about it, so that we can maybe eventually even use these sampling methods during some point in our lives when we need to collect data. But we also just want to be able to make sure that we know the strengths and the weaknesses of each. No one is perfect. Let's talk about convenience sampling. Convenience sampling is one that we tend to put at the bottom of the list. It's often very problematic. But after we go through this example, I'll give you another example in which it's really very reasonable method that can be used. As we go through these examples, let's think about if we were going to have that political poll that we talked about, and we're going to ask people ahead of some presidential election who they plan to vote for in an upcoming election, because we want to know who's ahead in the polls and who is likely to win. Now, convenience sampling is really a sample of convenience. We're going to talk to people, we're going to measure people who are easy for us to speak to. So for example, like at Ohio University, there are lots of students around. So I might conduct a poll with the students. Are they likely to represent the voting population of America? Probably not. And I think this graphic does a great job. You just see this woman hanging out a window saying like, hey, who are you going to vote for? He's convenient. He's just passing by. Well, does this guy necessarily represent the opinions of the voting population very well? You can see that there are some problems with this. So convenient samples are readily available, but are they likely to result in a representative sample? Probably not. Probably not. Imagine if we were going to do that political opinion poll, and we were just going to talk to people like in the Zanesville area. That's where we live. We live in this area. So we're going to go to the mall. We're going to go out in the parking lot. We're going to talk to people at school, maybe where you work, if you work in a hospital or in one of the schools. We're talking to people where we live. They're readily available. Well, do the people in our area represent the voting attitude of the entire U.S. population? Not well, no. I mean, I'm sure you realize that there are big differences in the way that people vote based on where they live. Some states tend to be more supportive of Democratic candidates. Some tend to be more supportive of Republican candidates, and so forth. Bottom line is, we need a much better cross-section of the voting population for the sample to be representative. Convenient sampling is likely to let us down in this situation. So those would be some of the problems. But as I mentioned, I wanted to give you just a quick example of how convenience sampling has its time and has its place. Let's get away from the political example for a minute and just imagine that we're doing some type of medical study. So let's say I'm some brilliant surgeon in the Zanesville area, and I have some new procedure that I've developed for dealing with cardiac patients. And I've finally gotten approval to test it on human beings. So I want to know if it works on people who meet certain criteria, for cardiac problems. So do I really need to find people from all over the globe? Or would it be reasonable to start by measuring people who have had this procedure in the Zanesville area? Because think about it. I mean, are people in Zanesville likely to respond to this procedure like people in Alaska? Well, I mean, in general, our bodies work about the same ways. So if it's successful here in Zanesville, it's probably going to be successful in Alaska. That's an example where convenience sampling would work pretty well. But when we're talking about attitudes, and we know that attitudes differ so much by geography, then we can't just focus on one convenient area like Zanesville. Okay, so convenience sampling in this case wouldn't work out very well. Let's talk about another sampling technique. And what we're trying to do now is start with this large group of people who are available to be in our study and then determine who's going to be in our study. Well, if we're going to just find people who are convenient, it ain't going to work out too well for us if we're doing a political poll. How about with simple random sampling? Simple random sampling is pretty neat. What this graphic is trying to convey is that, like let's say that I might just use some random telephone numbers to call people up. And the whole point of simple random sampling is that every single person in the population who we've identified who could be, possibly a candidate for a study has an equal chance of being chosen. So one thing that's very commonly done with political polls is to call people up. So we might randomly dial some digits. And of course, we can dial numbers in Zanesville, but we can also dial numbers in California, and Alaska, and New Hampshire. Hello, I'm conducting a poll for Ohio University, and I appreciate your input. If the election were held today, would you vote for Barack Obama or Mitt Romney? So my question to you, in general, is this technique likely to result in a representative sample? Now, let's be careful here. I'm training you to be very critical, and that's very important. A good science-minded person is a critical-minded person. We don't want to take that too far. We don't want to be cynical and think that everything is flawed and therefore it can't be used. Remember, none of these procedures is going to be perfect, but some are much better than others. And the key thing here is that I'm giving everybody an equal opportunity to be in my study. So I could call people up and ask them who they're going to vote, and I'm just as likely to get someone on the phone from Zanesville as I am to get someone from Alaska. That's a really powerful advantage of a random sampling type of procedure. Now that said, there could be some problems. There could be some problems. I mean, I'm likely to get a relatively representative sample, but it's not going to be perfect. I mean, none of these techniques are perfect. So I want you to think about what are some of the problems that we might encounter. Let me just give you a tip off of one. I mean, it's possible we'll call some people up and I'll ask them who they plan to vote for in the upcoming election. They might not even be registered voters. So we might need to incorporate some screening questions, right? So I call someone up randomly and ask them if they're registered to vote. So you see, it's already not as simple as it began. And then, does everybody have a phone? Does everybody answer the phone when they see some type of telemarketer calling or a pollster calling? You can see we have some problems, but we have to pick a procedure that's going to work the best for us. And we always want to think about what is the goal. What is our goal? We want to find a sample of people, those 600, 800,000 people, however many people we believe that we can measure reasonably, and we want their responses to be representative of that entire population. Always keep in mind that goal as you're evaluating these sampling plans. What about systematic sampling? As I mentioned, every single procedure has its strengths and its weaknesses. There are times that like we might be given some type of printout, for example. So I might go to a board of elections, say like, hey, I want phone numbers of all the registered voters. And they might be like, we don't have a way to provide you with that. We're sorry. If you pay 10 cents per page, we can print out the voter registration records, and from that you can get the information you need. So let's say I can get that. So now I literally have a list. How am I going to randomly select people from this list? One thing that you're starting to probably understand is when there's randomness involved in this procedure, it's likely that I will have an unbiased sample because I'm picking people randomly. I'm not using any type of systematic procedure. This is where it gets kind of interesting. If I have this list of people, I can use a systematic procedure that is still relatively random. Like let's say I want to pick every third person on this list, because if I pick every third person on this list, by the time I get to the end of the list, I'll wind up with like the 500 people that I need to sample and ask who they're going to vote for in the upcoming election. Well, if I pick just some random place to start, and I pick this person, and then I pick every third person after that, I'm likely to have a good mix of people. So my question is, in general, is this technique likely to result in a representative sample? And as long as this list starts out and that it's not set up in some type of organized way, then as long as I'm picking every third person or every fifth person, whatever it might be, I should get a relatively good cross-section of the people who are on that list. Because I'm not favoring any people. It's not like I'm picking the people just at the front of the list or the people at the back of the list or people whose name all begin with S's or end with L's, whatever it might be. Picking every third person. But there could be some problems. And this is unlikely in this scenario. In our scenario where we're trying to do a poll, I think it would work out well. But let's just say that this happened. Let's say that when the Board of Elections was putting together this list, they had people identifying themselves as independents, as Republicans, as Democrats. And for whatever reason, when they were working on the list, they decided like, all right, let's enter a name from the Democrats. Now let's enter a name from the Republicans. Now let's enter a name from the independents. Now again, let's enter a name from the Democrats, then the Republicans, then the independents. And do you see how now our list that we're working from actually has some system involved? And if that's the case and I'm picking every third person, I'm going to be getting a lot of these independent voters. So if our list is ordered in some type of way, there could be a problem with systematic sampling. Again, I don't think it would be a problem in our case, but that could be a problem with systematic sampling. And what's one of the keys here? We started off by randomly selecting a starting point and then selecting every third person. So people still essentially have an equal opportunity of being picked. Everybody has approximately an equal opportunity of being selected. That's a good way to start. Let's talk about another sampling method that's commonly used, cluster sampling. Cluster sampling is often used in exit polls. Remember, we are so obsessed with finding out who's going to win an election before the formal poll results come out, before the formal election results come out, that we conduct polls even right there on election day. And they're called exit polls. And they're called exit polls because we have people standing at the exits asking people who they just voted for. Now think about this for a minute. That's a lot harder than just calling people on the telephone, isn't it? I actually need now boots on the ground. I need people at these polling locations. That's going to start to require a lot of resources, a lot of people. So let's just say I plan to conduct exit polls at just 3 precincts from within our county. Let's imagine that this is our county and it's got like 32 different voting precincts. Here's the deal with cluster sampling. Cluster sampling always begins by taking our group of potential voters, potential people to be involved in our study, and we divide it up into groups. And these groups are these precincts that we see. We're going to just call them clusters. With cluster sampling, we call these groups clusters. Okay? And now here's the key. I'm going to randomly select some of those clusters. So let's say I randomly select precinct 5, I randomly select precinct 16, and I randomly select precinct 28. I could take 32 sheets of paper, fold them up, put them in a hat, and randomly select those precincts. Now, of course, I would want to randomly select as many as I can according to my resources, because again, I'm trying to get a good cross-section. What is my goal of any sampling plan? To get a good representative sample. So let's say I'm only able to really accommodate 3 different precincts. What makes cluster sampling is then I'm going to measure all the people in each cluster that I've picked. So I'm going to take my people working for me and I'm going to send them to every polling location in precinct 5 and every polling location in precinct 16 and every polling location in precinct 28. And as people walk out those doors, they're going to ask every single person, who did you vote for? Okay, so the key thing is that we're going to randomly select some clusters and we're going to measure everybody in those clusters. So again, my general question to you, in general, is this technique likely to result in a representative sample? Well, as long as I can pick random clusters and a sufficient number of clusters, it could result in a relatively representative sample. You know, and again, those things are big ifs. If I'm able to get random clusters and enough of the clusters to get a good cross section. So it's not nearly as clean as like a pure random sampling technique. But you know, sometimes I need to make use with the resources that I have and do the best that I can do. Now, could there be some problems? Well, the problems stem from the points I was making previously. I mean, it's possible now that Precinct 16 and Precinct 28 just tend to be really heavily Republican precincts in an otherwise Democratic county. And just by chance, I randomly selected those 2 precincts out of the 3, and now my results are skewed toward Republicans. That's why I need to have as many of the clusters randomly selected as possible. But I run into the problem of I only have so many resources. Okay? Well, if you want to figure out the results at the exits, you're going to need to make do with what you have. So we understand the positives and the negatives. Let's look at another one, which is really very unique and it's very powerful. Stratified random sampling. So with stratified random sampling, again, I'm going to take my pool of all potential people who can be involved in my study, and I'll break them up into groups. In this case, we call the groups strata. And they're still just groups, okay? So in this case, let's just say I'm going to break up my groups by sex, men and women, because we know there are differences in terms of how men and women vote. Systematically, women tend to vote more Democratic than do men. And there are a variety of other differences when it comes to the sexes. Let's say we're interested in looking at it that way. So I'm going to split all those registered voters into groups by sex, women and men. Here's the key thing now, because remember that word random is in there as well. I am now going to take random samples from each group. So from this group of all women, I'm going to randomly select some to be involved in my study. From the group of all the men, I'm going to randomly select some to be involved in my study. And for example, at this point, maybe now I'll call them using some type of random digit dialing method. I'm going to call them using the phone. So the beauty of this is that within each group, I get a good representative sample because I'm randomly selecting from that group. And within the other group, I'm going to get a good representative sample because I'm randomly selecting people from within that group. So not only will I get a good unbiased reading of women and a good unbiased reading of men, I can put them all together and I've got a good unbiased reading altogether. So it works out really well, particularly when I want to understand how different groups are going to vote. So in general, is this technique likely to result in a representative sample? Well, it involves random procedures, and random procedures usually do result in random representative samples for us. We really like that. Could there be some problems? Yeah, there can be some problems, just like with other studies that we talked about, particularly if I'm using some random digit dialing method. I can easily split people up by men and women, but again, I've got those problems that not everybody's going to answer the phone. A lot of people don't even have landlines anymore. There are certain laws about calling people with cell phones in different states. There can be some problems. But there are some really nice benefits to this as well. Think about it this way. Instead of splitting up all those registered voters by sex, male and female, it would make a lot more sense to group them up by their states. Because think about how a president wins an election. A president doesn't win an election by getting the most votes overall across the entire country. They essentially win by winning the most states or the most electoral college votes. So I really want to know what states will be won by each candidate. And if I can know what states they win, then I'm going to know who's going to win overall. So with stratified random sampling, what's often done is we're breaking up these groups of people by the state they live in. Then we're going to get a random sample based on each state. So I can figure out who's going to win each state because I have a good representative sample of people from each state. And I can put it all together and also get a sense of how the person's doing across the entire country. So there are some really nice benefits of that particular procedure. Let's go through just a couple examples, and we'll talk about this in class too to make sure you get it, and I'll quiz you a little bit. Check out this one. You identify the sampling method here. More than 400 votes were cast in the online poll at the ZanesvilleTimesRecorder.com. The question was, Ohio's new concealed carry law will go into effect April 8th. Will you apply for a permit? So people are reading the paper, they're seeing this question, they're able to go online to respond. What kind of polling method is this? What kind of sampling method specifically is being used here? Clearly not everybody from the community is going to answer the question, so the entire population isn't being measured. We're only measuring a sample. What kind of sampling method is being used? Now think about it. People are kind of selecting themselves, aren't they? They're reading the paper, they're finding this issue interesting, they're deciding that they have the time to actually respond to this, they're deciding to carry through and go to the website and respond. So ultimately it's a convenient sample. We often refer to this as a self-selected sample as well. Well, a self-selected sample is very convenient. They're really in the same classification. Ultimately it is convenient sampling. And we mentioned some problems with convenient sampling. And it's really very interesting when you go back and you look at the results of this. Many people responded that they were going to get these concealed carry permits. And it turned out to be some huge percentage of the responses. Only a small number of people in our county ended up getting concealed carry permits. So we can see that there clearly was a biased sample that responded to this question. Let's look at another example. A marketing expert for MTV is planning a survey in which 500 people will be randomly selected from each age group, 10 to 19, 20 to 29, 30 to 39, and so forth. The survey will ask about various MTV programming needs and things like that. So what kind of sampling method was used? The first thing that we can see is that they're going to be randomly selecting people. That starts off pretty good. Randomly selecting people from groups. So we have a group of people in this age, and this age. So what sampling method did we talk about that split the potential respondents into groups and then randomly selected people from each group? That was stratified random sampling. And what's really nice about stratified random sampling in this case is MTV is going to get a sense of the programming that people want overall, regardless of age, when they put all that data together. But they're also going to have a good representative read of people in this age group, people in this age group, people in this age group right here, and so on. And of course, those different age groups are probably going to differ in what they want to see. So you see how much information that gives? Stratified random sampling is really a very good sampling technique. So why isn't it always done? Well, you know, it requires a lot of people. If I'm going to have a good representative sample of people in this age group, I need to have a lot of people that I'm picking from this age group. You know, maybe I need 500 or 1,000 people just from that age group alone. And then also from this age group. It requires a lot of resources. All right, well, I'll talk to you more about this in class. Make sure you get it. What do we do when a sample is selected? Next, what we're going to discuss in the next video are different research studies. Because once we determine who's going to be involved in our study, well, we need to design the study. So we'll talk about designing research studies the next time we get together. So that, my friends, that's the key content from section 1.2. For now, that is all.